Right. So again, theory. So you have given a compound. So here one is ketonic groups. This is a ketone because there are two R groups on both sides, right? And the terminal part is a carboxylic group. Right. The first reaction is that they have used lithium aluminium hydride with water. So think about this a little bit. What is lithium aluminium hydride? It does the reduction of the compound. So here we have a carbonyl carbon, which can be reduced to OH here. So this will be reduced to a OH like this. Basically, alcohol. So there will be this CH2, and this carboxylic acid will be converted to a primary alcohol, CH2OH. Okay. Now tell me, if you have sodium borohydride instead of lithium aluminium hydride here, what is going to happen? You can use the chat box to answer me very quickly. Instead of lithium aluminium hydride, if you have sodium borohydride H2OH plus, what is going to happen? Remember, these two are reducing agents, right? Lithium aluminium hydride as well as sodium borohydride are reducing agent. But you need to understand its reducing power. That is very essential to understand. Remember, lithium aluminium hydride, okay, it won't reduce carboxylic group. Yeah, that's correct. So I have another answer that is given. The reducing power of lithium aluminium hydride is very high. Okay, so when you have either this carbonyl or even carboxylic, and also remember, if you have like even a ester group, CO, let's say COOCH3 is here instead of COOH. So when you have a ester even, a carboxylic acid even, a carbonyl carbon even, when you have lithium aluminium hydride, it can reduce all these. For an example like this, carbonyl carbon, it reduces to COOH and CH2OH. But when you have sodium borohydride, which is the reducing ability is little lower. In fact, it's considered to be mild. So this can only reduce these carbonyls. It cannot reduce either carboxylic or either ester. If you have an ester or either carboxylic, when you want to reduce, you need to use lithium aluminium hydride, which will give a primary alcohol both from carboxylic as well as ester. No problem in that. Okay. But when you want to just reduce a carbonyl compound, you need to use sodium borohydride because its reducing ability is poor. So try to understand here because it is necessary to understand this concept. Okay, so when you add lithium aluminium hydride and H2 and H plus, so S is formed. So S is this. So basically it should have OH and a CH2OH. So this can be accepted. This cannot be accepted. This is not reduced. This one is not reduced. This one is not reduced. So I have two answers that is possible. First one and last one. And again PCC. So this is again the other way around. You need to understand the difference between KMNO4, using KMNO4 and PCC. So peridinium chlorochromate, the PCC is a mild oxidizing agent, while KMNO4 is a strong oxidizing agent. Okay. So when you have KMNO4, when you have this primary alcohol, first it will convert this primary alcohol to a aldehyde. and then further it will oxidize this aldehyde into a carboxylic acid again. Okay, sorry. But when you have PCC, which is a mild oxidizing agent, it can only do this first step, which is it can produce an aldehyde. That's all. So here it should produce an aldehyde. So here we can see it has produced an aldehyde, and at the same time, this PCC also can oxidize this carbonyl compound to its same CO. So this is correct and this is wrong. And finally, there will be a Clemmensen reduction again, where oxygen is added by 2 hydrogens. So you can see these 2 oxygen is converted to 2 hydrogen. So the correct answer is first one. Okay.